Okay, example 5 is all about Ernie the Exponential. In our first part, we're going to talk about whether Ernie is increasing or decreasing. The function itself is x squared times e to the x. Be careful on this. It's been a while since we did product rule, but as you can see, we've got one function times another. In this case, one function is x squared, the other is e to the x. It might be helpful to write out to those two functions to the side and do our old-fashioned scaffold, where we take the derivative of x squared and get 2x. Derivative of e to the x is e to the x. We find out our first derivative, which is crucial in finding our increasing and decreasing intervals. Our first derivative is x squared e to the x plus 2x e to the x. Second step, always finding your critical points. F prime is equal to 0 or f prime does not exist. None of these terms right here will produce a spot where f prime doesn't exist, so we just need to worry about setting f prime equal to 0. When we do that, we notice that we can factor out an x and an e to the x and set this equal to 0. When we do, we get x times e to the x times x plus 2. Remember that when you're trying to find roots, you need to use the zero product property and set your roots equal to 0. That is critical here. We get roots whenever the x is equal to 0 and whenever x plus 2 is equal to 0, which produces the root of x is equal to negative 2. Notice that e to the x is never equal to 0 for real numbers, so we don't have a critical point that comes out from that. We've got our two critical points, which are 0 and negative 2, so of course we put those on a sign test. Notice that e to the x is always bigger than 0, so we only really need to concern ourselves with the x times the x plus 2 to the part. Let's test the number to the left of negative 2, like x is equal to negative 3. When we do that, we get negative times a negative, which is a positive. In between negative 2 and 0 would be a number like x is equal to negative 1. We get a negative times a positive, which is a negative. And a number bigger than 0, such as x is equal to 1, we're going to get a positive times a positive, which is a positive. Thus our conclusion, f is increasing on the interval negative infinity to negative 2 and 0 to infinity because f prime is bigger than 0. Again, you need to make sure that you reference your sign test. You don't just conclude with the sign test. The sign test doesn't tell us anything by itself. We need to interpret it. F is decreasing on the interval negative 2 to 0 because f prime is less than 0 on those intervals. So Ernie's got two intervals where he's increasing and one interval where he's decreasing.